Hello everyone. In this video we'll see some of the remaining properties that we were discussing in the last lecture, and we'll also see some new things on series. So for today's lecture we'll consider this series. As you can see, it has elements as 1, 8, 2, 3, 7, 4, 9, and it has user defined indices or what do you say, labeled indices as A, B, C, D, E, F and G. And I've already written the code here to create the series. Let me actually display the series once. So yeah, so this is the series. Okay, so the first property that I'm going to explain today is values property. Okay, so of course it's a property, so please remember not to put these brackets around it. Okay. Alright, so what does this values property do for us? So simply you can understand this as it gives you the values of the series, okay, and not the indices, and you will get the result as a list. So let me actually use it here. So I'll print a blank line first so that the output is clear, and then I will print s dot values. Okay, so now when you run, you can see that you are getting these values printed on screen. So this is what values property does. Now you often make mistakes in writing this property like this. Okay, so it is of course wrong. So remember, it is values, okay, not the value. Now you can also use this property in a loop if you want to iterate through items one by one. So let's make a program. So for example, I want to print all even numbers from this series. Okay, that is 8 to 4. Okay, so how do we do it? So obviously you can use a loop. You have to use a loop on this. So the one thing is you can use index property. Of course, index property we discussed in the last lecture. So I'm doing it with index property for now. So for I in s dot index. Okay, so what am I getting in this variable I? Indices of these items, and since I have these labeled indices here, so I'll be getting these only, okay, one by one in this variable I. So you can simply put a condition here inside the loop as if s of I modulus 2 is giving you 0 value. So this is how you decide whether a number is even or not. Okay, so we are basically checking the divisibility of each element with 2. So if it is 0, that means it is an even number. So you can simply print s of I. So this is the program. So let me run it, and yes, you can see that the even numbers are getting printed. So now I'm going to do it with values property. Okay, so let me delete this code here, and now I'm going to write for I in s dot values. Okay, no brackets, remember. So now the question is, what am I getting in this variable I one by one? So it's no longer indices, guys. Okay, I'm getting values directly in this variable I. So the first value which is stored in this variable I is 1. The second value is 8, then 2, 3, 7, 4 and then 9. So you can directly put a condition on the variable I itself. Okay, do not assume that this variable is index of the incoming element. It is directly the element. Okay, so if I modulus 2, now this is giving you 0, then you simply have to print I. So this should do the job, as you can see from the output. Okay, so this is what values property does. Now another property that we need to understand is size property. Okay, and size property gives you the number of memory blocks in the series. Okay, so right now I have what do you say, 7 elements. So obviously the size is 7 because I have 7 memory blocks. So let me actually use this property here. So let us have a blank line, and then I'll write print s dot size, and now when you run you can see that the size is 7. Okay, simple. Now what happens when I have an empty memory block in the series? Okay, so for example, this is the series, and for some reasons I want this value to be empty. Okay, so how do you represent empty values in a series? So there is a special value which is called NaN, and this is how it is written. NaN stands for not a number. Okay, so NaN basically means that the memory block is empty, or simply the value is unknown, you can say. Okay, so how do we create a series with NaN values in it? Okay, so there are 2 different ways of doing it. Okay, so the easier way is to, like here for this variable 3, you can simply write the keyword none. Okay, so let me delete these lines from here. Okay, now when you run and see that, you will see that this is now empty. Okay, now once you have an empty value in a series of numbers, so earlier it was all integers. Okay, so remember that as soon as NaN comes, all the other integer values will become float type of values. Okay, so this is happening because of this NaN. So don't worry about why this 0.0 is appearing here when we have given all integers here. Okay, so it is just because of NaN. All right, so this is one way of specifying NaN values. But if you use this keyword none in case of string values, okay, if you have string values in a series, so for example, if I have a string value, say for example P, and then you have Q, and then R, and then none, we'll keep none here, and then S here, and then T, and then U. Okay, so now we have all string type of values here, with one value I want to keep as empty. So let's see what happens now when you run this code. Now see, so instead of saying NaN, it says none here. It doesn't matter, it is still an empty value. Okay, so don't worry about that. But if you want to be a little consistent with NaN values, I recommend you to use the second method. So what's the second method? Okay, so now what you can do is you can import numpy module, and let's give it a name as np, and then here instead of writing none, you can write np.nan. So this is a property of numpy module, and this is same as writing none, so no difference whatsoever. It is just that it is it appears as nan always, no matter what type of other values are there. So this is what I like. Okay, fine. So let's run and check if we are getting an empty memory block there or not. So we are getting it. Fine. Now coming back to our property, which was size. So now when you check the size, now when you check the size of the series, what should we get as output? Now you might think that since we have an empty memory block, so the size of the series now should be 6. Okay, well, this is not going to be the case. The size is still 7, as you can see. And why is that? Because the size property counts the memory blocks in the series. It doesn't have to do anything if the memory block is empty or not. Okay, so I hope the size property is clear to you. The next property is called empty property. Okay, so let me actually write it here first. Empty. Okay, so obviously it gives us whether we have an empty series in our hands or not. Okay, so how do we create an empty series? Okay, so in order to create an empty series, you can simply write s is equals to pandas dot series and keep these brackets empty. Now this is definitely an empty series. Okay, so if you print the series on screen, you see that it shows empty. Now these empty square brackets means that the series is empty. Okay, all right. Now when you use this property s dot empty, so what output should we be getting? True. Okay, why true? Because the series is indeed empty right now. Now what happens when you do have some elements? So if I specify 10, 20 and 30 here, so the series is definitely not empty and we are going to get the result false. Okay, now what happens when I have all these elements given as NaN? So this is NaN and this is NaN and one more NaN. Okay, makes no sense of course, but it's just that I want you to understand something, that's why. So I have this series in which I have 3 memory blocks, since you have written 3 NaNs here. Okay, so logically if you think the series is still empty, but look at this output, when you run it, it says false, and I hope you understood the reason of this. Okay, so again the empty property targets number of memory blocks in the series. So even if the block is existing and it has no value right now there, it is still going to be considered. Okay, and hence the series is not empty right now. And same goes for the size property. If you check the size of this type of series, it is going to be 3, as you can see, because there are 3 memory blocks. Okay, so I hope these properties are clear to you. Okay, so now let's talk about some of the important functions that you can apply on a series. Okay, so you can you have so many functions, but I'll take the important ones right now. So you have a function called as head, then you have tail, then you can have a sum function applied in order to sum the elements, then you have min function to find out the minimum value, max function, and then you have count function, we'll see it in a minute, and then we have mean. Now this mean is average, guys. Okay, so if you want to calculate the average of the elements of a series, then you have mean function, so just remember the name. And then of course you have median function, and then you have mod function. Okay, so these are this is what we use in statistics. Okay, so these functions that I'm selecting right now are also called as aggregate functions in Python Pandas, so remember this term. Okay, all right, so let's see one by one how they work. So let's first of all discuss head and tail functions. Okay, so head function gives you elements from top position of the series. Okay, so gives top 5 elements, you can see. Okay, and if you want top 3 elements and not the 5 elements, you can write this parameter 3 here, and then it will give top 3 elements, or I should write, let me correct this thing, gives 5 elements from top. Okay, this makes more sense, and this gives 3 elements from top. Okay, so this is how it works. And similarly, if you want top elements, or I should say 7 elements, for example, from top position, then you can simply write head 7. So it is just that if you don't write anything inside these brackets, you will get 5 elements from top position of the series. So this is the head function, and same goes for tail function, guys. So if you write tail function and if you don't write anything here inside these brackets, what is going to be returned? So it, in this case, it will give you elements, or I should say 5 elements from bottom. Okay, and if you want 3 elements, obviously you will write tail 3, and then if you want 7 elements from bottom, you will write tail 7. So I hope it is very, very simple for you to understand. So let's now check them out here. So let me write print s dot head. Okay, so now when you run, you can see that this is the original series. Okay, and then you have these 5 elements getting displayed. Easy. Now let me change here. So let me write head 5 or head 3 here. So now when you run, you should get only 3 elements from top. Okay, 3 elements from top. Similarly, if you write tail function, okay, so if you write nothing inside the brackets, it should give 5 elements from bottom, as you can see. So these are the 5 elements from bottom, as you can see in the output. Now the thing here is that the order in which the elements will appear in the tail function is always like from top to bottom. Like, you know, if you are taking 5 elements from bottom, the order will start from here only. So this is first element, then second, then 3, 4 and 5. So this is how it is going to be taken. It is never like this element, then this, then this, and then this, and then this. No, it doesn't work like that. Okay, so the elements will appear always from top to bottom, even when you use tail function. Okay, so similarly, if you write tail 3, you should get 3 elements from bottom, but keep an eye on the order in which they appear. Okay, so this is basically it for head and tail functions. Okay, now if you want to calculate the sum of all these elements, you can simply use s dot sum, and you don't have to write anything inside these brackets. Okay, so now when you run, you can see the output is 34, which is the sum of all these elements. And obviously, if you want to get the sum of a specific range of elements, then you can write it like this. So for example, if I want to calculate sum of these 5 elements, so you can always use slicing here. So let me write a colon e. Okay, so I'm using the labeled indices for this slice. So am I getting 5 elements now? Yes, because in case of string type of labeled indices, the stop index is always included. All right, so I have supplied this data, I have selected this data, and on this data I can apply, what do you say, sum function. So if you run it now, you can see that now it is showing 21, which is the sum of these 5 elements, as you can see. Okay, of course, now if you know head and tail function, you can use them also here in order to get the sum of 5 elements. So you can simply write s dot head. Okay, so what will it give? Top 5 elements, and then you can put one more dot, and then you can write sum. So as you can see, it works even now. So Python is a very flexible programming language, guys. So you can use so many different ways of solving a particular type of problem. So this is one of them. Okay, all right. Likewise, you can get a minimum value by simply using s dot min. Do not write anything here inside these brackets. Okay, and you run it. It says that the minimum value is 1, which is indeed correct. Okay, as you can see. And if you want maximum value, you can write max, and that's it, you get the maximum value. Easy. And if you want to calculate average value, then you have to use the function mean. Okay, there is no function as avg or average in Python for calculating average values on series. Okay, so you have to use mean function only. So as dot mean, and then when you run, you can see that you have this number. Now of course you can adjust this portion, decimal portion, up to required number of digits if you want. For that you need to use what do you say, round function. Let me see how it works. So you can use round before this, and then you can enclose as dot mean inside it. So, and then you can put comma 2 here. So let's see if it works or not. Yeah, it works. So as you can see that the number is rounded off up to 2 decimal places, and that looks better now. So this is basically how you can apply these aggregate functions on a series. Okay, let's now talk about some mathematical operations that you can perform on series. So for example, if I have a series, pandas.series, and let me keep it absolutely simple for you. So if I have only 3 elements, 1, 3 and 4 for example. Okay, now I'm keeping the default indices here, 0, 1 and 2. Okay, now if you want to add or subtract or multiply or divide anything from each element of this series, okay, so how are you going to do it? So you may think of applying a loop on it, and then you can do it element by element and so on, but series gives you a much better option. So the series supports what do you technically call it as vector operations, in which you can apply a mathematical calculation directly on a series. Okay, and if you apply that operation will be applicable on all elements of the series one by one. We also call it what do you say, broadcasting technically. Okay, so for example, if I want to add the value 10 to each element of this series, okay, so for that I can simply write it s is equals to s plus 10. Now remember to write this s is equals to thing, because if you don't, then this series will not be overwritten. Okay, fine. So now let's see if it works or not. So I've printed the series, and let's see what output do we get. Yes, so as you can see, we are getting the values 11 and then 13 and 14. So the value 10 is added to all elements. Okay, so now how about multiplication? So you can do it the same way. So you can simply write s is equal to s multiplied by 2 for example. So what is going to happen? Each element will be multiplied by 2, and then the series will also be overwritten. So you can simply run and you can see, so each element is getting multiplied by 2. Now one little thing here that you need to be aware of is that this is not possible on list. Okay, so had it been a list, let me change it for a minute. Okay, so now this is no longer a series. Okay, this is a list. So when you apply a multiplication operation on a list like the one you can see right now, you have a replication. Okay, that means the list itself will be repeated these number of times. So I have written multiplied by 2, so this means you want to replicate the list 2 times. So now when you print the output, as you can see, you're getting 134 and 134 2 times. Okay, and of course the original list is updated because you are overwriting it. Okay, so I just wanted you to understand the difference between list and series here, that list doesn't support any type of arithmetic operation in the manner in which they are applied on series, in the manner in which I am explaining you right now. Okay, so this is another difference between a series and a list, right? So list doesn't support vectorized operation. This is how it's technically called. All right, let's come back to our series. Now, of course, if you simply print s multiplied by 2 here, okay, now this will temporarily print the required output, as you can see, but is it affecting the original series? No, it is simply printing it. Okay, so if you print the original series, then you can see there is no change in the original elements. Okay, so it's up to you. If you want to overwrite the original series, you can write that equals to sign, the assignment operator, and then the operation. Okay, or you can simply print it like this. So I hope it is clear to you. Now another type of operation, mathematical operation that you can apply on series is that when you have two or more series objects, okay, and you want some calculations to be performed between them. So let's see it with an example. So if I have a series S1 declared as this, and then I have S2, one more series I am creating here. So pandas dot series, and then you have, what do you say, 5, and then 2, and let's take 8 here. Okay, so I forgot to put these square brackets here, right? So I have two different series objects here. And now what happens if you want to print the sum of these two series objects? Okay, so obviously for that you can simply write S1 plus S2. Okay, and then if you run, you can see that it is working perfectly fine. So what is happening here? Okay, so the operation which is being performed here is of course addition, but this addition operation will be performed only at matching indices. So you must remember this. Okay, so you have index 0 in the first series, you have index 0 in the second series. So 0, index 0 plus index 0, so this is 1 plus 5, ultimately 6. Same thing is happening here. So you have index 1 here, index 1 here, the elements will be added, index 2 here, index 2 here, the elements will be added. Okay, now of course you can use you can store this result in another series like this. So S3 is equals to S1 plus S2, and then you can print S3. So now if you see, you have the same output, but you have stored the result in another series. So this is also you can do. And of course the addition of two series is always a series, so remember this. Okay, now what happens when we do not have same index existing in both the series? So let me make few changes here in both the series objects. So in first series, I'm going to specify the labeled indices as A, B, and C. Okay, and in the second series, I'm going to specify, let me keep them all same for now. So this is also having A, B, C. So now we have a match for each element in both the series objects. So let's see what happens now. It works the same way, as you can see. So index A will be added to index A, B will be added to B, and C will be added to C. But what happens when you make a change here? So for example, in the second series, in place of index C, what about index X? Okay, so now it has two matching indices in both the series and one non-matching index in each series. So what happens now? Let's see what happens. Let's run it and see. So as you can see, it is not going to show any error, guys. Okay, so now you have to understand this output. Okay, so as I said earlier, that the addition operation is going to happen only at matching indices. So the system found a match for index A, so it it calculated 5 plus 1 or 1 plus 5 you should say. Okay, then it found a match for index B in both the series, so 3 plus 2 5, and then it searched for index C. It found index C here, and then when the system looked for index C in the second series, it was never there, so it simply put NaN here. Now you might think that it should have been 4 instead of NaN, okay, but I'm coming to it in a minute. It will be clear to you why. Now similarly, when you look at this element 8, it has index X, okay, as you can see here, and there is no match for index X in the first series. So again, the output is going to be NaN for this index. Now remember, in the result, all the indices will appear. This is what you must remember. So if I ask you how many indices do I have right now collectively in both the series objects S1 and S2, so you will say we have 4 index. So A and B are common, and then C and X. So this is how you can, this is what is happening here in the output. Okay, so I hope this concept is clear to you. Now coming back to this NaN value, okay, now there's one very important property in Python Pandas that you should remember, and that is any value plus NaN is going to give you NaN. Okay, so that is the reason why we are getting NaN at index C and NaN at index X. Now if you compare the same type of operation on a list, okay, so let me convert this code for a list. Let me do one thing. Let me delete this pandas.series from here and from here, and delete the rest. Fine. Now I have S1 and S2, but they are no longer series objects. They are lists, two different lists. Okay, so I'm adding them up here. So what should we get here? Now, as I said earlier, you cannot perform any mathematical operation on list directly. It is simply not supported. So in this case, you might think that there is going to be an error. Well, that is not the case. When the addition operation happens between two lists, okay, those two lists are concatenated. They are going to be joined with each other, okay, and of course the result is being saved in this third variable S3. So this S3 is again going to be a list, because list plus list is a list. So what output will we be getting in that list? Okay, so as I said, they will be concatenated or joined. You can think that 1, 3, 4 and 5, 2, 8 will be joined, okay, and it will form a completely different list. So let's see what output do we get. So I hope you expected the same output. Okay, now it will never be like two different lists inside a list. No, it will be one single list. You can also call it that two lists will be merged in order to form a single list that way. So I hope this is clear to you as a difference between series and a list. Okay, all right, so very important concept. Let's come back to our series. Now there's one more case I wanted to discuss, and that is, what if I have matching indices, for example, as you can see here, and if you have uneven number of indices. So for example, if I have 4 elements here in the second series, and obviously we'll have to have 4 indices as A, B, C, D. Now what? Okay, what happens when you perform an arithmetic operation? So let me directly write S1 plus S2. Now what? Okay, so obviously the matching indices will have the operation performed on them, and if any match is not present, then it will put NaN there. So based on that explanation, you can simply imagine the output, I guess. So as I said earlier, the output will have all the indices that are present collectively in both the series objects. So we have in total 4 indices. So A, B, C, these are common, and then we have D as a non-matching index. So obviously again it is going to have a value NaN here. Now let's see what happens when we have same index for multiple elements, and then an operation is performed, a mathematical operation is performed. So for example, in the second series, I'm going to keep index for all the elements as A. Now what? Okay, so just pause the video for a minute and then just think of the output. Okay, I hope you will get the correct one. So again, the same rule applies here. For all the matching indices, the operation will be performed, and for each non-matching index, the operation will not be performed. So based on that, you can simply imagine this output, I guess. Okay, now what happened here? So obviously we did not have any match for index B and C. So in front of B and C, it is going to put NaN values for sure. But for index A, it found 3 matches. Okay, so obviously for each match, it will have to perform the operation. So for the first match, this A plus this A, then this A plus this A, then this A plus this A, ultimately 1 plus 5 and 1 plus 2 and 1 plus 8. This is what is happening here. Now, what happens when you have different order? We have matching indices, but the order is different. So for example, if I specify the order of indices in second series as this is C and this is A and this is B. So what happens now? Okay, so let's see. We'll run the program and just look at the output and the code side by side and then try to understand. So as you can see, it still found match and then the operation is performed. So this index A and this index A. So the addition will be performed between these indices for the index A. So it is 1 plus 2. So 1 plus 2 is 3, and same is happening for index B, 11, that is this 3 plus 8, and then this C plus this C, that is 4 plus 5, 9. Okay, let's see one more case here in which I'm going to have some NaN values put in the series. Okay, so for example, let me get rid of these indices and come back to the default indices 0, 1, 2, same for both the series. Okay, now I'm going to import this module numpy, and then on purpose I'm going to put an NaN value here as in the second element of the first series, and one here as the third element of the second series. So now what? Okay, now what happens when you add them? So let me first print the series objects side by side. So print S1, then I'll have a blank line, then print S2, then I'll have a blank line, and then this addition. Okay, so what output do you expect from this? So let's run and see what happens. So if you observe carefully, you can see that for each NaN value, it took NaN only in the result. So this is same as what I said earlier. Okay, so this NaN plus this 2 is going to be NaN. Okay, and this 4 plus this NaN is also going to be NaN. So this is how it is working, and same property will be applied on all the arithmetic operators. What do I say? The addition, subtraction, multiplication, division, floor division, and all of them. Okay, so I hope this property is clear to you. So that's it for this video. We'll see some more operations performed on series in the next lecture. Okay, till then, take good care of it.